Morning, Pre-Calc students. We're going to talk about functions today. So, we've got some notes here, fill in the blank. I'm not going to read everything to you. Take a second to do that. Go ahead and pause your video if you need to record that information. Okay, hopefully you've had a chance to record that information. The biggest thing from there is domain is X, range is Y, domain is left and right, range is up and down. We've got function notation and interval notation. That's just how we write things. We're trying to, again, I know it might be confusing to learn, but we are trying to write less. Knowing symbols, if you just think about certain messages and emojis and text message lingo, were created by people because they didn't want to type a whole word out. And so they've created lazy ways to try to get around writing out a whole word. It's the same thing with math. We're creating symbols so we don't have to write as much. Okay, so let's get into determining whether these are functions or not. So basically what we're looking for, do any of the x's repeat? It's kind of what you're basing it on. Because if none of the x's repeat, as long as there is an output that's a feasible output, then it's a function. So I look at letter A, notice 7, 9, 9, 8. Well, I got two 9s here. They can repeat as long as the y's repeat, because it's the same point. The same point can happen over and over again on a graph, but letter A is not a function because of this. Basically, I compare it to if you're taking the ingredients to make a cake, and you make a cake, and then you take the ingredients to make a cake, and you make a baked potato, that doesn't work. It's kind of the idea of a function versus not a function. So over here, that's a function. Each domain has its own unique output, and it's not repeated. So this is yes. Down here, functions from A to B. Well, if this were from B to A, then it would be yes, but our range is in our domain, and our domain is in our range, so that's no. And then over here, well, we have each domain being used, and each output is there. You might say, well, can it repeat? Well, if you graph these points, we're going to talk about the vertical line test here in a little bit, it will pass the vertical line test. You can have the y's repeat. And the example is there are different ingredients to make cakes. Different ingredients to make cakes. I can make it by scratch. I can buy a store-bought cake and make a cake. So that's kind of the idea of a function versus not a function, at least in terms of using points. Okay? So determine whether the equations are functions. Use the vertical line test. So we may want to graph these, so we will have to solve for y. So we're going to bring in some technology here today. So if I solve for y, I got that. All right, I just bring the x squared over, but it's negative. Then over here, I have to solve for y. So I got y squared equals x plus 1. And then I got to take a square root. So then y equals, be careful here, you need plus or minus. Remember, anytime you take the square root of x or y squared, you need to have a plus or minus. So we need to have that plus or minus there. Okay? So, go ahead and get your calculator. Right, so we're going to go ahead and graph it on our calculator. If you don't have a calculator, you can always go to Desmos and graph it that way, desmos.com. That works. So we're going to graph negative x squared plus 1. That was our first example. And so we got a parabola going down. Does it pass the vertical line test? Can you draw a vertical line that touches the graph at two different places? If you can, it's not a function. So as long as it can hit the graph no place, that's okay. If it hits the graph one place, it's okay. So for our example here, for part A, this is a function. This is yes. It passes the vertical line test. So we're good. So now we need to graph the other one. So I go back to y equals, and I'm going to delete those. So what's my problem? X plus 1. Better double check. You don't want to graph the wrong thing. Yeah, it's x plus 1. It's plus or minus. If you remember from our other example, the other day. We need to graph it as two separate equations. Our calculator doesn't do plus or minus. It's just one of those things where we're going to graph it as two separate things, but we're really treating it as one. So when I graph it, can I draw a line that touches the red and the blue? Yeah, I can draw a bunch of them. So that tells me that this is not a function. Not a function. A vertical parabola is a function, a horizontal parabola is not. All right, so here's function notation. So it's g of x, this is the way you read it. G of x equals negative x squared plus 4x plus 1. So the way you read this is g of 2. So g of 2 equals, you're going to take 2 and plug it in for x. So everywhere you see an x, you plug in a 2. So this x got turned into a 2, this x got turned into a 2, and now you simplify. Be careful, this negative is not inside the squared, so it actually is negative 4. When you square 2, you get 2, and then you put the negative there. 4 times 2 is 8, plus 1. So negative 4 and 8 is 4, plus 1 is 5. You might say, well, letter B, what do we do? Well, we're going to plug in everywhere we see an x, we're going to plug a t. I'd say, well, okay. Actually, not a lot of work to do for this one, so it's going to be negative t squared plus 4t plus 1. Again, what's the practical use of that? Not a whole lot. That's not really going to be that useful for us, but just it's practice to understand what function notation is, how to read it, and how to use it. We just need to be aware of that. Over here, we're going to have a little bit more work to do in letter C. So we're going to take everywhere we see an x, we're going to plug in x plus 2. So we're going to have negative x plus 2 squared. Again, I know there was an x over here, but this x, just like we replaced this x with a t in letter B, this x is getting replaced with the whole thing of x plus 2. So that's why it has to be in parentheses, because you got to square that whole thing. And it's going to be plus, we had a 4 there, and then I got to have an x plus 2 where I used to have an x. And then I still have that plus 1. So this used to be just x, this used to be just x, now it has to be x plus 2. So we do have to simplify. Be careful, you got to FOIL that. So that's got to be x squared plus 4x plus 4. You got to write it out twice. Write it up here. You got to write it out twice. And then multiply. And then here, this is 4x plus 8 with plus 1. Distribute your negative. So we're going to have negative x squared. Nothing else for it to combine. I got a negative 4x and a positive 4x. Uh-oh. They just cancel. Negative 4, 8, and 1. That's 5. So that's function notation. Now we get into the piecewise functions. Piecewise functions, I think of it looking at it like a condition. There's different pieces. So if I have no money, if I have less than 0, just think of that if that were another number. If I have less than a certain amount of money, then I go eat here. If I have more than this amount of money, then I can go eat here. This is just like the condition. This is the equation piece. These are the pieces. And then these are the conditions. So over here it says x equals negative 1. So before I plug it in here, which condition is met? Is it less than 0 or greater than or equal to 0? Well, for this one, this is the first piece. So I need to plug it into the first piece. So x squared plus 1, plug in negative 1. So that ends up being 2, because you square negative 1. 1 plus 1 is 2. All right. So then letter B. before I plug it in, I got to figure out which condition. 0. Is 0 less than 0 or is 0 greater than or equal to 0? So this is the second condition, second piece. So you take x minus 1 and you plug it in. That's negative 1. And then our last condition, it's 1. 1 is definitely greater than 0, so this is the second piece. So x minus 1 is the piece that we're looking at, so it's 1 minus 1, which is 0. So find all real values of x such that f of x equals 0. So that's, remember, f of x is just like y. We want to find when y equals 0. What makes this equal 0? I got to plug in 0 for f of x and solve for x. I need to know what x values. I'm finding the x-intercept is another way. Practice that last lesson. So I'm going to add 2x to both sides. And then I'm going to divide by 2. So if you plug in 5, you get 0. So that's what makes it equal 0. So for this one, we're going to plug in 0. Do you remember how to solve a quadratic? Because that's really what we're doing. We've got a factor. No GCF. Nothing special. We'll look at special things later. But we have to factor. So what multiplies x squared? X and x. What multiplies to 6? 6 and 1. 2 and 3. They have to add or subtract to 5 because that's the middle term. Notice both of them do. So I got to look at the signs. Signs, second sign is positive. It means they're the same. First sign's negative, they're both negative. So they have to add to 5. So am I going to be able to get 6 and 1 to add to 5 or 2 and 3 to add to 5? 2 and 3. So my answers, if you set each of them equal to 0, x equals 2 and x equals 3. So for this one, we need to find all values for x for which f of x equals g of x. So you're just going to set these two equal to each other. And then we got to solve. So we got x squared, so let's try to get them on the same side. Add x squared to both sides. So I got 2x squared. And then I'll bring over my 3x. When you have a quadratic, you want to try to set it equal to 0. Now we got to try to factor. There's no GCF, nothing special, so we got to write our parentheses. Reverse FOIL or magic X box method. 1 multiplies 2x squared, 2x and x. 1 multiplies to 1, 1 and 1. There's not much thought process here because they can't multiply to anything else. Signs are the same. They're both negative. So solve this. You get x equals 1. And here you get x equals 1/2. Over here, set them equal to each other again. So x squared minus 1 equals 0. Negative x squared plus x plus 2. So we're going to add x squared to both sides again. Got 2x squared. Let's bring over our x, so we subtract it, and then a minus 1. So set that equal to 0. So let's try to factor it again. There's no GCF. Again, I always say that because if you don't get the GCF, sometimes you will be unable to factor. So what multiplies to 2x squared? 2x and x. What multiplies to 1? 1 and 1. Sign is negative. Second sign is negative. That means they have to be different. The bigger number has to be negative. So out of this, these are the inner and the outer terms when we factor. If you know the magic X box better, then you can use that too. So this needs to be negative. That needs to be positive. Remember, the signs have to be different, so you can't have them be the same. The bigger number, so this is 2, and that's 1. So that has to be negative. So we finish by solving. This is a negative 1/2, and this is 1. So those are our two answers that make that true. Okay. We're going to finish up domain and different quotient on a separate video, so check that out.